Good morning, students. Today we are going to discuss about electromechanical energy conversion in multiple excited magnetic system. So இங்கே multiple excitedன்றது வந்து என்னன்னா doubly excited எடுத்துக்கிறோம். Doubly excited means we have two excitation source of excitation. Okay, so we are taking this for doubly excitation. See, இங்கே ஒரு excitation இருக்குது, இங்கே ரோட்டாருக்கு ஒரு excitation இருக்குது. So when we give two excitations, the rotor tries to have some angular displacement of theta due to the torque. Okay, so இங்கே அதே தான், we are giving some electrical energy and the energy magnetic field store ஆகுது, and that energy stored in the magnetic field is again helps for the angular displacement. Okay, so this is a source V1 and the current is I1, the source V2 which provides current I2 for this excitation, the flux linkage lambda 1 and lambda 2 for source 1 and source 2. Okay, so we are considering torque developed as TF. For continuous energy conversion we need multiple excited systems. Okay, we need multiple excited system. Here we have double excitation. Okay, again and again we are telling the same thing. Here we are having double excitation. Okay, so for single excitation T is equal to we know the equation dou F dash by dou theta, correct? That is increase in co-energy. அதே மாதிரி என்ன பண்ணணும், T is equal to minus dou F by dou theta, correct? This is for single excitation system, single excitation. The same thing now for rotary movement for double excitation. So TF is equal to dou WF dash, the co-energy is a function of, remember this I lambda curve, correct? This is lambda I. Okay, this is co-energy and this is energy. I hope you remember this one. So it's varies over 0 to I, correct? Co-energy and energy varies from 0 to lambda. As we have two excitation, it is a function of I1 comma I2 comma theta by dou theta. Here it has three independent variables, correct? So I1 and I2 and theta. Similarly, in terms of co-energy, correct? So we can write minus dou F by dou theta, where the field energy is a function of lambda 1, lambda 2, comma theta. Okay. For case 1, we will take for case 1, okay, that is the torque due to, we'll take this as for WF of lambda 1, lambda 2 and theta. Okay, we'll discuss for this one. So we know WF of lambda comma theta is nothing but in 0 to lambda, correct? 0 to lambda, we'll take that I into d lambda for a single excited system, correct? Single excited system. Same manner, now we have WF of lambda 1, lambda 2, theta. How we can write this as 0 to lambda 1 I1 into d lambda 1, correct? Plus second source, we have 0 to lambda 2 I2 d lambda 2, correct? And we cannot simply இதை என்ன பண்ண முடியாதுன்னா அப்படியே டைரெக்டாக வந்து இன்டகிரேஷன் பண்ண முடியாது, பிகாஸ் I1 is the function of flux linkage. அப்போ first வந்து we'll write the flux linkage. So flux linkage lambda 1 is, we know lambda is equal to Li. It's a self inductance. So இதில் ரெண்டு flux இருக்கிறதுனால we have self inductance as well as mutual inductance concept, correct? So we can write L11 I1. This is a self inductance due to its own current. So L12 I2, correct? And similarly lambda 2 flux linkage in the coil 2 is again L21 I1 plus L22 I2. This L12 and L21 are we know this is mutual inductance, correct? Mutual inductance. Okay, and then L11 and L22 are self inductance. Okay, self inductance. Okay, so now our aim is to find out I1 value as a function of lambda 1, or similarly I2 as a function of lambda 1 and lambda 2. So let us have this as equation 1, this as equation 2. First we eliminate I2. So to eliminate I2 eliminate பண்ணனும்னா first equation எதை multiply பண்ணனும், second equation எதை multiply பண்ணனும் அப்படின்னு பார்க்கலாம். So here we have to multiply it by equation 1 should be multiplied by L22 and equation 2 should be multiplied by L12 so that we can eliminate this one. Okay, so L22 lambda 1 L22 lambda 1 is equal to L11 L22 I1 plus L12 L22 I2. Similarly the second equation we are multiplying it by L12, correct? So L12 lambda 2 is equal to L12 L21 I1 plus L22 L12 I2, correct? Subtracting these two equations, so subtract these two, so what happens, this gets cancelled. So we can write this as L22 lambda 1 minus L12 lambda 2 is equal to L11 L22 I1 is common, correct? So shall we write L12 L21 of I1. We need to find out I1, correct? So I1 is equal to we can take this here, so L22 lambda 1 minus L12 lambda 2 divided by L11 L22 minus we can take L12 mutual inductance or same, correct? So that we can take this as L12 whole square, so L12 whole square, correct? I am just still separating this one. This separate panna enna varuna L22 divided by, because I will need I1 in terms of L1 and lambda 1 and lambda 2. அதனால என்ன பண்றேன், numerator denominator தனித்தனியா பிரிக்கிறேன். Okay, so L11 L22 minus L12 square of lambda 1. Okay, this is the coefficient of lambda 1 minus L12 divided by L11 L22 minus L12 square, its coefficient of lambda 2. So we can write this I1 is equal to beta 11 lambda 1 will take plus beta 12 lambda 2. Okay, let us take this as equation 4. So beta 11 is the coefficient of lambda 1. So what is the value of beta 1? Shall we write coefficient of beta 1 is 1 as coefficient of lambda 1, which is nothing but L22 divided by L11 L22 minus L1 to the whole square, and beta 12, correct? Beta 12, which is coefficient of lambda 2 is, we'll take this as minus L12 divided by L1 L22 minus L1 to the whole square. Okay, so let us have third equation, this one I1. Similarly, you have to find out for I2 by elimination method, same elimination method, or we some other substitution method, but it's good always to have elimination method. So again, to eliminate this variable I1, no, what we have to do, equation 1 is to be multiplied by L21 and equation 2 is to be multiplied by L11. Okay, see, after doing the multiplication, so we'll get this one, then again we have to subtract these all. So what happened, this one, okay, will get cancelled, become 0. What's the pending? We have L21 lambda 1 minus L11 lambda 2 is equal to I2 is common in both the cases, so shall we have this as L12 dot L21 minus L22 L11 of I2, correct? Now we have to find out I2 by taking this component in the left hand side. Now see, I2 is equal to L21 lambda 1 minus L11 lambda 2 divided by L12 is equal to L21, so we'll get L12 the whole square minus L11 and L22, correct? Now I am separating these things as a quotient of lambda 1 lambda 2 எடுத்தோம்னா L21 divided by L12 square minus L11 L22, correct? Then minus of L11 divided by this is quotient of lambda 1, so we can take this quotient as beta 21, correct? L11 divided by L12 square minus L11 L22, and quotient is quotient of lambda 2. So I can rewrite this as I2 is equal to beta 21 lambda 1 then plus beta 22 lambda 2. So my beta 21 is this one, correct? Beta 21, which will be equal to beta 12, correct? Is equal to L21, we can check it out. L12 the whole square minus L11 L2, it is L22, correct? L22, correct? Similarly beta 22 is equal to we will take this minus L11 divided by L12 the whole square minus L11 L2. See here, okay? So previously we have found out the same thing. Beta 11 is L22 divided by L1 minus L12 square. Beta 12 is minus L12. See here, if we take this negative outside, this beta 12 and beta 21 will be same. See here, beta 12 and beta 21 will be same. Now we can substitute this I2 and I1 as a function of lambda 1 and lambda 2 in this equation, okay? Now the integration is valuable one, so I'll take this then I substitute, okay? So what we get here is WF of lambda 1 comma lambda 2 comma theta is equal to integration of lambda 1 I1 lambda d lambda 1, correct, plus I2 d lambda 2 0 to lambda 2. Just I will substitute here 0 to lambda 1. I1 is nothing but what we have, beta 11 lambda 1 plus beta 12 lambda 2, okay, into d lambda 1 plus I2 value is beta 21 I1 plus beta 22, sorry, it's a lambda 1, correct, lambda 2 d lambda 2. Further I am separating this integration, so I can separate this as two component, correct? 0 to lambda 1 beta 11 lambda 1 dot d lambda 1 plus 0 to lambda 1 beta 1 to lambda 2 d lambda 1, correct? Then this is again further separated as two terms, correct? So how I can do it? 0 to lambda 2 beta 21 lambda 1 dot d lambda 1 plus 0 to lambda 2 beta 22 lambda 2 d lambda 2. For the first component and fourth component I can directly integrate. How I can do beta 11 lambda 1 square by 2, correct? For this one beta 22 lambda 2 square by 2, correct? For these second component and third component எப்படி இருக்குன்னா beta 12 and beta 21 are common, correct? So shall we take beta 21 or 12, correct? The integration is 0 to lambda 1 comma lambda 2, correct? I can write this as third term. See here, this is actually lambda 1 d lambda 2, d lambda 2. Here I'll get d lambda 2. So what we'll get here, third term is lambda, sorry, we'll get this first term as d lambda 1, correct? This is d lambda 1 and this is d lambda 2, correct? So if you take beta 1 and beta 2 common, we'll get lambda 2 d lambda 1 plus lambda 1 d lambda 2. So how it looks like, lambda 1 and lambda 2 are interrelated, correct? Both are two different independent variables. So we can write this as differentiation over lambda 1 and lambda 2, correct? So I can write this as beta 1 1 beta 1 1 lambda 1 square 2 plus beta 2 2 lambda square 2 plus, you can write beta 2 1 or beta 1 2, correct? 0 to lambda 1 comma lambda 2 differentiation of d lambda 1 lambda 2 இந்த மாதிரி எழுதணும், because there are two independent variables, correct? So ரெண்டுமே வந்து differentiate பண்ண முடியும், அதனால lambda 1 and lambda 2, correct? So either differentiate panna will get lambda 1 lambda 2 only. So the final answer is, so wf of lambda 1 comma lambda 2 comma theta will be equal to 1 by 2 beta 1 1 lambda 1 square plus 1 by 2 beta 2 2 lambda square plus beta 2 1 lambda 1 lambda 2, okay? So if we differentiate with respect to theta, we will get the torque produced by the magnetic field or change in electric field, okay? Similarly, we are going to discuss about torque due to co-energy. Again, we are going to discuss about TF due to WF dash, which is a function of I1 I2 theta. So நம்ம எப்படி வந்து WF கண்டுபிடிச்சோமோ அதே மாதிரி தான் WF dash of I1 I2 theta is equal to integration over 0 to I1 whenever no lambda 1 di1, correct, plus 0 to I2 lambda 2 di2. So இதில் இன்ட்ரெஸ்டிங் என்னென்னா, no need to go for further further simplification. lambda 1 என்னவோ அது அப்படியே டைரெக்டாக சப்ஸ்டியூட் பண்ணுங்கள். So we'll get 0 to I1 I1, what is lambda 1? L11 I1 plus L12 I2 di1, correct? Then plus integration of 0 to I2 L21 I1 plus L22 I2 di2, okay? So அங்கே எப்படி பண்ணமோ அதே மாதிரி தான் இங்கேயும் பண்ண போகிறோம், எந்த சேஞ்சஸும் கிடையாது, சேம், all the things are applicable here also. So first இதை செப்பரேட் பண்ணுறேன். 0 to I1 L11 I1 di1 plus 0 to I1 L12 I2 di1. So again separating these, correct? The third term is 0 to I2 L21 I1 di2 plus 0 to I2 L22 I2 di2, correct? So same, how we found out the field energy, same manner co-energy, okay? The first term and third term we can directly integrate. So what we get, L11 I1 square by 2 plus for the third term L22 I2 square by 2, correct? The second and third term we can write as usual, L12 is equal to L21. So both are equal, hence I will take only one component and remaining components are common. 0 to I1 I2 2 integration. So I can write this as I2 di1 எழுதலாமா plus I1 di2. So I1 and I2 are independently variable, அதனால இது எப்படி எழுதலாம், differentiation of I1 and I2 எழுதலாம். So L11 I1 square by 2 and then L22 I2 square by 2 plus L12 integration of I1 I2 differentiation of I1 I2. So if you integrate this, you will get only I1 I2, correct? So I can write this as WF dash of I1 I2 theta எப்படி எழுதலாம்னா 1 by 2 L11 I1 square plus 1 by 2 L2 to I2 square plus L1 to இது integrate பண்ணிங்களா integration and differentiation cancel I will get I1 dot I2, correct? This is your co-energy in the doubly excited system. Okay, so what is the torque produced? Torque F is equal to dou F dash of I1 comma I2 comma theta divided by dou theta, correct? இதில் எது வந்து ஃபங்க்ஷன் ஆஃப் எக்ஸ் அப்படின்னு பார்த்தீங்கன்னா நமக்கு வந்து இண்டக்டன்ஸ் இஸ் ஃபங்க்ஷன் ஆஃப் எக்ஸ் ஆர் தீட்டா, கரெக்ட்? இண்டக்டன்ஸ் தான் எப்போவுமே நம்ம ஏர் கேப்போட இது வேரி ஆகும்போது டிஸ்டன்ஸ் ஏர் கேப்போட டிஸ்டன்ஸ் வேரி ஆகும்போது என்ன ஆகும்னா இண்டக்டன்ஸ் வேரி ஆகும். சேம் மேனர் ஆங்குலர் டிஸ்பிளேஸ்மெண்ட் வேரி ஆகும்போது வேரி ஆகிற ஒரே காம்பனண்ட் இண்டக்டன்ஸ். அப்போ இண்டக்டன்ஸ் ஷுட் பி ரெப்ரசன்ட் as differentiation of this one, correct? So இதில் வந்து இது ரெண்டும் கான்ஸ்டன்ட் ஆகிடும். So I'll get this as 1 by 2 I1 square dou L double 1 by dou theta, correct? அடுத்தது I2 square by 2 directly right, I2 square by 2 dou L22 by dou theta, correct? Again I1 dot I2 அப்படியே போட்டுட்டு here dou L12 divided by dou theta. This is the torque produced by the doubly excited system. Okay, so very interesting one is this. Hope you understand this concept. Thank you all for watching this.